So one deliverable I had to create as part of this project was a set of machine learning models capable of detecting elephants. Now, unfortunately, I wasn't able to use the drone to collect aerial footage of elephants. So I've had to make do with a public data set of animals, and the data I used was called Animals 10 from Kaggle, and it contained images of 10 animals, among them were elephants. Now, these images of elephants weren't from an aerial view as would be viewed from the drone, so this model wouldn't be ideal if used on the drone, but the hope is that the code I wrote in Python and TensorFlow to train this model can be reused once appropriate training data has been collected. So I'll give a quick demo of the machine learning models I created, and we'll choose a picture of an elephant to identify. Okay, so there are different types of models that I tried to create. Using Python and TensorFlow, I aim to create a set of image classification models, and I also used Azure Custom Vision to create some object detection models. Now, the difference between image detection and object detection is that in image classification, we're aiming to tag the image as a kind of single label. So essentially, we'll say, okay, this image is of an elephant. Whereas in object detection, we're not only trying to identify what tag is associated with the image, we want to identify the location of where that tag occurs in the image, and also kind of how many of them are in the image. So the small CNN and VGG CNN, these are image classification models that I created, whereas Azure Custom Vision, that's an object detection model. And you can immediately see the difference is that the Azure Custom Vision model shows that there are two elephants being detected in this image, whereas the image classification models simply say that the image is of an elephant. Now I want to discuss the image classification models first before moving on to the Azure object detection models. So the small CNN, this is a convolutional neural network, which is essentially a neural network that works with images. And this was one that I was making when kind of first learning about how the CNNs work and kind of experimenting with different hyperparameters. So this CNN was able to get an accuracy of 77%. Now, the VGG CNN is a convolutional neural network based on an architecture called VGG16. This is an architecture developed by a group of researchers in Oxford. And you can see that the accuracy is 20% higher than the small CNN, it's 97%. So what's shown here are the architectures of the two machine learning models, which I'm not going to go too in depth in here. What I do want to talk about though are these plots here. So this is the accuracy plots and the loss plots. Now, what we ideally want is for the blue line and orange line, which represent the training accuracy and validation accuracy respectively. We want them to be fairly close to each other, and we want them both to be quite smooth lines. So with a small CNN, you can see that the validation accuracy isn't a smooth line. It kind of jumps about, it's quite erratic, and it doesn't always stick towards the training accuracy, although it generally follows the same trend. Contrast that with the VGG CNN, and you can see that the validation accuracy is a much smoother line, and in general, it stays much closer to the training accuracy. And that's reflected in the performance as well. The VGG CNN had a much higher accuracy. Here we have a set of metrics for each, and I'm going to discuss more about what precision and what recall is soon. But F1 score is essentially a combination of both precision and recall, and it's like a one number to describe how well the model was performing for that tag. So for each of these tags or labels we're trying to detect, the F1 score can be thought of as just one number to indicate how well it performed. Now we have the confusion matrices, which I wanted to talk about. So on the left-hand side, we have the actual label, and on the bottom, we have the predicted label. So one way of reading this is to say, okay, 99% of actual elephants were predicted as being elephants. Or here we have 60% of cows were predicted as being cows, and 28% of cows were predicted as being sheep. So using this, I want to talk about precision and recall. So precision is saying of everything that we predicted as being an elephant, what proportion of those predictions were correct. So you can see here kind of 11% of squirrels were predicted as elephants, 16% of sheep were predicted as elephants. There's a lot of things that were misclassified as being an elephant. So due to that, the precision of the elephant label is going to be quite low. Recall is sort of the opposite of that. It's saying of everything that actually is an elephant, what proportion of those did we predict correctly as being an elephant? So here we can say of all the things that were actually elephants, 99% of them were predicted as elephants, hence why the recall is going to be 99%. And if we look at the metrics for elephant here, you can see, like I said, precision for elephant is going to be quite small because many things were incorrectly predicted as being an elephant, whereas the recall is quite high because most of the things that should have been predicted as elephants were predicted as elephants. Now, if we contrast the confusion matrix for the small CNN with the confusion matrix for the large CNN, you can see the VGG CNN, is it's much cleaner and much tighter, and it's much less variance in the predictions. Now, I want to discuss the Azure object detection models. So I've already mentioned how they're different to the image classification models, but the interesting part here is that they're actually able to identify not only if elephants are in the image, but also how many elephants are in the image. You can see here detected both of these elephants with these confidence values. So to explain this further, I'm going to go into the custom vision portal on Azure. Okay, so you can see I trained this model on 107 images of elephants. In contrast with the image classification model, that was trained on about 1,300 images of elephants. And the reason that there's much fewer training images for the object detection model is that in order to train the images, or to train a model on the images, each image has to be manually tagged to tell the model where in the image the elephants are. And this can be quite a time-consuming process. So this is one of the drawbacks of object detection. However, the performance I managed to gain was 97% precision and 84% recall, which for only using 107 images in my training data is quite good. And you can also see here the predictions. We can see exactly where the elephants are being identified and also with what confidence. So if we look at the image that I uploaded to the demo website, you can see here identified an elephant here and an elephant here. What I also wanted to do with object detection is I wanted to see whether or not the Azure services could detect elephants from a top-down view. Now, as I mentioned, I didn't have, or I wasn't able to use the drone to collect top-down aerial views of elephants. So I've had to go online and try to find aerial images of elephants. And there aren't many, and what there are aren't high quality. So you can see lots of them have kind of watermarks on them, or kind of, bad crops and things like that. And there's also not many. I was only able to find 59 images of aerial images of elephants. I also included aerial images of bison as well, just to see if these dual models could differentiate between elephants and bison from the air. So just to make sure it's not, just identifying blobs from the air. It's actually looking for specific things that differentiate an elephant from another animal. And another reason why there's not much data here is that for every single image, I've had to manually tag this where the elephants are. So again, that's also a very time-consuming process. But the performance here, it's not as good as the other one, mainly due to there not being sufficient amount of data and the data being quite poor. So 88% precision, 71% recall. But if we look at some of the predictions, you can see here it's capable of identifying these elephants from an aerial view. And here it's able to identify kind of these are bison, not elephants. So overall, I think that in terms of the drone use case, I think it's best that a object detection model is used. I think that mainly because with the object detection model, you can not only identify if there's an elephant in the kind of frame, you can also identify how many elephants there are and whether the elephants are moving, if they're stationary. There's a lot more use cases you can fulfill with the object detection models. The only drawback is that it does take more effort and more work to kind of train, simply due to having to manually tag them.